Greetings, welcome to the first produced video I ever made for this channel. I am more or less just shouting this into the void, so who knows if anyone will see this. Anyways, this is Pitaka 42, a wireless mechanical keyboard bound in leather running ZMK firmware. Here's how I designed and built it. I got into the hobby from frequent hand paints I got while playing Super Smash Bros. Melee on a keyboard. It's a really high actions per minute game, coupled with my bad wrist posture led to really bad pain flare-ups even in short sessions. I wanted to space out my hand more to reduce straining in my wrist. I built a 70 key Redux Sandware as my first ergonomic keyboard. It's really practical but bulky. After a while, I wanted to explore more ergonomic layouts. A lot of them reduced the number of keys, reducing having to stretch my fingers to reach them. I settled on a 42 key layout, axing the number row and the bottom row, moving their functions to separate layers to keep functionality. It took a while, but I got used to it eventually. This project started last year as wanting to make a leather carrying case for my existing split keyboard, since I have to travel a lot. Since I'm not using all the keys anyways, along with the keyboard being quite thick, I could redesign it for my use case and save some space. If I'm already designing for portability, why not ditch the carrying case entirely and have the keyboard be designed out of the case material I was gonna use? After settling on the idea, I started to make some concept art to flesh it out. I imagine it sorta like a wallet you can fold in half, with the keys being clustered to either sides and a gap between them. I modeled the design in Fusion 360. I started with a layout of keys I found online that I liked. I ticketed it into a plate and started to build out the features. Then from there, I modeled the pattern of the leather that will wrap onto it. After iterating on the design for about 2 weeks, I ended up with a shape and thinness that I wanted. From there, I printed the leather pattern on paper and made the model on my 3D printer. On with the leather parts. I'm choosing a chocolate brown and gray color scheme for my design. I'm using 6-ounce chrome tan leather. It's more supple and flexible than veg tan leather, so it should stretch around the 3D print without needing to mold it beforehand, and mostly because it's what I got on hand. I cut the templates out of the paper and cut the leather into more manageable chunks. Then paste the templates, then cut it into shape. And lastly, using my stitching chisels to punch out holes for sewing later. For the components, I use Otemu low-profile red switches. 2mm solid copper wire I cut and bent to shape. An NRF 52480 microcontroller. This handles Bluetooth communication as well as the keyboard logic. It works by assigning pins on the chip to certain rows and columns. Then, when you connect the row and the column by pressing a switch, it will know which key to send to the device. Some diodes, a USB-C extension adapter, batteries, and bits and bobs I scavenge from old toys or electronics. To start soldering, I needed to snap in the switch to the main body. I am using a process of hand wiring I learned from YouTuber Joe Scotto, in which he connects the switch rows, columns, and diodes using solid copper wire. It gives the keyboard some decent rigidity and produces solid solder joints, only if you can solder properly, which I certainly can't. Though, I later learned that the solder I was using was really that bad. I started by connecting the columns by slotting the copper wire between the pins and the switch stem. Then soldering them in place. Then on to connecting the rows, first by soldering the diodes to the other pin. Preparing the bent copper wire by marking and adding heat shrink tubing to prevent it from touching the column. Placing it just above the switch. Wrapping the diode leg around it and soldering it in place. Trimming the diode leg afterwards. I repeat the same process to the other half. To continue on soldering, I first need to connect the two halves together, so the wire spanning the gap will have the right length. I added some double-sided tape on top of the plate and stuck on the leather panel, aligning the holes by poking through some sewing pins. I clamped it into my stitching pony and started to sew. Stitching this was a bit cumbersome because my stitching needles sometimes get stuck on the small holes of the plate, needing me to pull it out using a pair of pliers. But eventually, I went around the pattern, trimmed the excess string, and locked in the thread by melting it with a lighter. I repeated the same process to the other side. I did a similar process of taping and pins to add the leather bridge to now connect the two halves. I'm using silicone wire. It's thin and flexible. I can easily snake it underneath the copper wire through to the other half. I organized them into a flat row of wires and taped them. I left a bit of a slack to form a U-shape and soldered them to the microcontroller. Lastly, I added a bracket that will zip ties the wire to the plate, preventing the wires from being pulled and possibly breaking the solder connection. I did the connection of the other half off camera, and that's the wiring and soldering done. I'm doing a partial assembly to work on the firmware and test if everything works before permanently showing it shut. For keycaps, I'm using KLP Lame by Brain Defender. On to the firmware. Please do not look at this as a tutorial to build your own firmware. I am a big dumb and just brute forced my way into making it with substantial help from the ZMK Discord. And this is outdated anyways since ZMK updated a few times since I recorded this. But the gist is, I made a new repository in GitHub, paste this initializing script onto Git Bash. I picked the microcontroller and layout template as well as link to my repository. After opening it in a text editor, I edited the template to fit my configuration. For my design, it's still mostly QWERTY, but with so little keys, other functions have to be moved to certain layers. I designed mine as base layer has letters, second layer has numbers and symbols, third layer has mouse navigation, media controls, and the function row. Fourth layer is a gaming layer for games I can't remap that easily, looking at you Rivals 2. And the fifth layer has Bluetooth settings and the keyboard configuration. After building the firmware, I downloaded it and set my microcontroller into bootloader mode by shorting some certain pins. It will appear to the PC as a removable drive. All I need to do is copy the firmware file and it will automatically go through the flashing process. Now that it's partially complete, here's a brief demo of me using it. My poor typing speed aside, this has a really good soft typing feel to it, and the switch that I use have very little noise. Everything works now. But before I do the final stitching, I wanted to mention if you watched this far into the video, I guess that you've enjoyed it. So, only if you think I've earned it, a like and a subscribe would be really appreciated. Here are the leather panels for the back pieces. I glued some neodymium magnets to the back leather bridge to act as a clasp. I started with the stitching between the leather bridge and the top halves. Then I started working through the right half, through the bridge, to the other side, and around back, circling the whole perimeter, stitching to its final completion. And that's it, it's finally complete. At the time of writing, I've been using this keyboard in my daily life for about a year now. This keyboard was worth the effort making it. It's such a pleasure to type on, and I always love having a connection to the things that I use. It's been quite the tedious process of designing and making this for the first time, while trying to remember to film myself all throughout. Video editing, trying to wrangle so much footage and weave it into a narrative is overwhelming at times, but enjoyable when I get into a rhythm. Anyway, I am no Texwell Drive or Andy. I'm an illustrator and a tinkerer. I'm obsessed with miniaturizing and optimizing the things that I use. I do a lot of these projects involving leatherwork, 3D printing, and recently more electronics. Subscribe if you'd like to join me on my next weird idea.